Assalamu alaikum dear students, hope you are all fine. Today we are going to discuss few problems of uncertainty which will help you to understand the discussion which we had in the last lecture. And here we are dealing with these you can say problems, and we will try to understand the equations which we have developed for different you can say situations of uncertainty. State the most appropriate instrument or instruments for the measurement of the following. Number one, the diameter of the wire of diameter about 1 millimeter. So you know that a screw gauge is the instrument which has least count 0.001 millimeter. So I think that the screw gauge will be the simple answer. On the other hand, the resistance of a filament lamp. So as far as the resistance is concerned, you know that R is equal to V over I. So you better use this situation here, and you know that for voltmeter we use voltmeter for the potential V, and we use ammeter for the measurement of current. So simply you can write that the answer is simple, and voltmeter and ammeter, these are the two instruments we have to use. Or even there is another instrument which is the complete instrument which can directly measure the resistance. So ohm meter is another instrument possible. The peak value of an alternating voltage. Here actually we have not studied alternating voltage in detail, but you know that the current which changes its direction continuously is the alternating current. And we normally use an instrument, and that actually, as I said, that we have not discussed this as such in detail. So I'm just giving you the idea that cathode ray oscilloscope, cathode ray oscilloscope is the instrument here, which is known as CRO. With the help of CRO, you can determine or you can measure the peak value of the alternating voltage. As I said that we are for the time being not going into the detail of cathode ray oscilloscope. Here actually the question we have to focus, and this question is about the uncertainty. So the mass of a cube of aluminium is found to be 580 gram with an uncertainty in the measurement of 10. So uncertainty means absolute uncertainty is 10 gram. And what we can do, simply we can write first that M plus minus del M is nothing but 580 plus minus 10 gram. So it's better to write in this way. So this will help us to calculate the required parameter. Each side of the cube has a length. So length of the cube is given with the uncertainty, and what we can write as given 6.0 plus minus 0.1 centimeter. So this is what we have. Calculate the density of the aluminium with its uncertainty. Express your answer to an appropriate significant numbers or figures. So this is what we have. Actually, as we have discussed already, that whenever you will have these type of questions, so first of all you must know the definition of the density, and the density, if you are representing by rho, mass by m, and volume by v. So you can also write that we are dealing here with the volume, but the volume is not directly given, but its length is given. So we can say that it is nothing but L cube, because it is the cube. So all the sides are of the same length, and the length is given. So we can write the formula of the density in this way, that m divided by L cube. Now the first point is that we need the value of density, and then we will go for the, you can say, uncertainty in the density. So first, when we are going to calculate, or we need to calculate the density, so formula is very simple. So you can write in this way, that we know that what we know that density is equal to mass per volume, per unit volume, or L cube. So simply we can write here that the value of mass is given as the value is given as 580, and the value of your length is given as 6. So 6 power cube you will have, and when you will calculate this result, approximately 2.68 the value you are getting. Even you can write 2.7 or 2.7. The significant figures, as we have two significant figures here or one here, so the best the appropriate significant figures we can use is only of 2. So this is what we have as far as the density is concerned, and you know that this is measured in gram per centimeter cube. So this is the first step, you can say. Then when you will go for the another step, which is your you can say calculation for the uncertainty in the density. So we will use the following equation. What we have, it's very simple. Here you have the situation of your calculation for the absolute uncertainty, which is, you have to recall actually the formula. So here actually as we have discussed before, that if Z is the quantity which is the product of x and y, so what we have to do for the uncertainty of Z, del Z over Z is equal to del x over x plus del y over y. So simply you can write here that we have the situation of del m over m plus del L over L. But here you have to recall one more thing, and we have discussed this point as well, that if we have the relation in this way, that we have a power of the variable, so in this case delta x over x will be given as 3 into del r over r, yani the exponent will come before the fraction part of the uncertainty. So here, as you know, that we are dealing with the L cube, so simply you can say that it is nothing but 3, and here you have to include 3 as well. So the actual formula will be something like this: 3 multiplied by this one. Okay, so this is what we have. And then of course you have values like del rho you want to calculate. The value of density you have already calculated. I am just using for the time being 2.68. Then plus minus del m is 10 divided by 580. On the other hand, we have 3, del L is 0.1, and the value of length is given as 6. So this will be the situation, and when you will calculate the result for this part, what you are getting, here you have the situation that you have the result over here as 0.02, and here you have 0.05. So ultimately what you are getting, that here we have del rho and when you will use this you can say quantity 0.07 and of course 2.6 you have to multiply on the other side, so del rho is coming as 0.187. Again, as far as the appropriate significant number is concerned, this will be only 0.2. Remember one more thing, and this is very simple to understand, that as we are talking about the confusion or uncertainty, so mostly we will use the uncertainty in you can say one significant figure. So this is something which is you have to remember, and when you will solve more problems you will understand that what we are doing and what we are saying. So simply the answer will be 2.7 and plus minus 0.2. So this is what we have to do for the calculation of your uncertainty with the value. So this is what we have as far as the problem 1 is concerned. Then we can go for, suppose, this problem. Again, this is only one part of the problem, you can say, where we are dealing in this you can say question, and the question here is question 9. A student uses a meter rule to measure the length of a elastic band before and after stretching it. The lengths are recorded as length of the band before stretching is given as L0, and this is the value. Length of the band after stretching LS, and this is the value. So two quantities you have, and you can see that we are dealing here with the difference, the change in the length LS minus L0. So first of all, you can quickly recall what we have studied as far as the addition or subtraction of the values are concerned. So LS, or simply you can say that if you are considering x plus minus del x, and another quantity is y plus minus del y, and you want to subtract x from y, so what you have to do, simply y minus x, this will give you the value, actual value, and the plus minus will give you the uncertainty in this way, that you have to add the absolute uncertainties of the values or the given quantities. So simply this is the situation. So this we will apply here as well, and what we are saying, that LS minus L0, this is the quantity required, and this is something which is like Z over here, or this quantity. So LS minus L0 plus minus del LS plus del L0. Remember one thing, that whether you are going to subtract or add, the the absolute uncertainties will always be added, or you have to add these uncertainties. As far as the values are concerned, here you have 51.6 minus 50.0, and for the absolute uncertainty, what you have to do, you have to add their absolute uncertainties. So very simple thing, and here you have 16 1.6, not 16, plus minus 0.2. So this will be your answer simply, and here you are writing the change in length, quoting your answer with its uncertainty. So here they have given only LS minus L0, but what the question is saying, quoting your answer with uncertainty. So you will not write only 1.6, but you have to write in this way, that this is the answer. Hope you are getting what I am saying. This is the situation of subtraction of two quantities with their uncertainties. So the point is that whenever you will subtract the quantities, the values, the calculated values or given values will be subtracted, and their uncertainty always be added. So this is another example which we have discussed. Then here we have another question, and this question is again about the situation which we have discussed, and this is the you can say question here. A student takes reading to measure the mean diameter of a wire using a micrometer screw gauge. So this is what we have here. What the question is, that here we have make suggestions, one in each case, what the students may adopt in order to reduce a systematic error in the reading. So you know that when we were discussing the systematic error, this is the error in the system. So what we can do for reduction of the systematic error? So either we will use the new, you can say, instrument, or what we can do, we can check the value of this zero error. So simply you can write that what and how we can reduce. So reduce a systematic error. So you can simply say that what we are doing here, or what we have to do here, that we will check the zero error. Check and correct the zero error of the instrument. So simply this is what you can do. Allow for a wire of varying diameter along its length. So what you are doing, they are saying that allow for a wire of varying diameter along its length. Yani the wire is not of the same diameter, but it is of different diameter. So what we have to do, so simply what you can say, that we will take reading along the length, take reading along the length of the wire at different points or positions. So in this way you can rectify your error. Allow for a non-circular cross section of the wire. So if you have something like this, then this is not a circular you can say cross section area. So in this case what you have to do, you will take the readings, around the wire spirally. Yani you will rotate your screw gauge, you will suppose fix somewhere here, then you will take, suppose this is position 1 2 3 4 5. So at one point you will fix your screw gauge in between 1 and 3, then you will fix your screw gauge in 2 and 4, and then you can fix 3 and 5. So in this way spirally you will move your screw gauge, and in this way you can find out the nearly correct value. So this is what we have as far as the measurement is concerned. Now we are going for the uncertainty thing. So the mean diameter, the part P is, the mean diameter of the wire is found to be 0.50 plus minus 0.02 millimeter. Calculate the percentage uncertainty in the diameter. So remember one thing, that here they have given you directly the value of the diameter with the uncertainty. So simply what you have to do, you have to recall the formula of the percentage. So if D is the diameter, so del D divided by D into 100, this will simply give you the answer here. So this is 0.02 divided by 0.50 multiply by 100, which is giving you the value of 4%, yani plus minus 4% is the uncertainty, which is the percentage uncertainty, and this is the answer you can write here, that this is plus minus 4%. So the first part of the problem is for the percentage of the diameter. Now as far as the second part is concerned, the area of the cross section of the wire. So now you know that we can write in this way, that the area of the wire, if given as A, then A is equal to pi r square. So what you have to do, simply you need to calculate the area of the cross section, and basically what we have to consider, percentage uncertainty. So simply what we can write, thus del A over A is equal to, now the pi is something which is a constant, so you need not to consider the you can say uncertainty in pi, because there is no uncertainty in pi, it is just a constant. But as far as your given data is concerned, they have given you the diameter, but here you have the radius. So first of all, what you can do, you can write in this way, that the formula will be in this way, that pi d over 2 whole square. So simply you can say that, as I just told you, that pi is not the quantity or the value which we have to use for this particular uncertainty thing. So simply you can write that 2 del d over d into 100. This will give you the percentage uncertainty, and of course here you have to multiply by 100 as well. So this will give you the percentage uncertainty in your area. So simply what we can do, what we can write, that here we have the percentage uncertainty of area, or in the cross section area, and the value is given for your del D as 0.02, and then you will have the value of 0.5, and of course multiply by 100. So this is something you can do, but here we have another situation, and the situation is that the part which we are considering for the percentage, like this part we already have calculated here, and this is something which is very important, and directly we can write the value of this part. So this is nothing but 4. So the value of the uncertainty in the area is coming as 8. So simply you can write plus minus 8, that's it. So this is how you can calculate this particular thing. Got it? Then we will go to another question, and actually the purpose of solving this question is not to just solve these questions, but to you can say revise the topic. So remember this thing, that what is the intention behind this you can say lecture, and this lecture is basically the continuation of the previous one. So if you want to get the full benefit of this lecture, you have to check the last discussion where we have discussed the uncertainty thing, and of course your systematic error and random error and accuracy and precision as well. Here you can see again in this question they are talking about, in part A, they are talking about distinguish between the systematic errors and random errors. So how you will distinguish? Systematic error is simply, you know, is the error in the system, or you can say that the error which is due to, or error due to the instrument, or even wrong assumptions. Again the same thing, we have discussed these points in the previous lecture. So if you have any confusion, go back and the lecture before this you will help you. Random errors, so simply you can say the errors which do not have fixed values, or simply you can say that the errors due to the observer or you can say the environment change, but I think error due to observer is enough. If you want to get 1 mark, this will give you 1 mark. Then again, the main point is that we are discussing the uncertainty things. So as far as the uncertainty is concerned, here you have the question, part B. A cylinder of length L has a circular cross-section area of radius R as shown in figure. So here you have the length L is the cylinder and R is the radius of the cylinder. So these are two things, and they have given you the value of the volume and length. Volume and length. The volume V of the cylinder is given by the expression, and the volume and length of the cylinder are measured as, so they have given you volume and length. So calculate the radius of the cylinder with its uncertainty. So again the same thing, as you have the equation, so directly use, first of all, the first step will be, you can write here, we know that V is equal to pi R square L, and when you will use their given values, and remember one thing, that the unit is same on both sides, so you need not to do anything else. Just 15.0 is the value of the volume. Here remember one thing, that pi R square L is the formula given, and you know that the value of the pi is nothing but 3.14. So just write this value as well. R square, you are actually going to calculate R, so I'm just writing R square, and then length is giving as 20.0. The calculation of this R simply will give you the value of the 0.489. So this is the first step, where you have calculated the value of R, the value of the quantity for which you are going to calculate the you can say uncertainty as well. Now as far as the formula is concerned, they have given you this formula, and this formula will help you to calculate the absolute uncertainty of R. Now the thing is that whether you have the division, like suppose if you are going to write R square, so how you will write R square? This will be V divided by pi into L. So this is what we have. So as we know that for the absolute uncertainty, what we can do now, here we have the formula for your absolute uncertainty. You can write in this way, that del R over R is equal to plus minus del V over V plus del L over L. Yani these two quantities, V and L, these two quantities will have the uncertainties, and of course the pi is a constant value, so there is no possibility of uncertainty here. So what you have to do now, just use the values like 2 del R you need to calculate. R you have already calculated, so 0.489. Over here you have plus minus del V is 0.5. The value of V is 15.0, and del L is 0.1, and the value of length L is 20.0. So this is what you have. The calculation is giving you, I'm not going to calculate the whole thing just to save the time. The calculation del R will give you the value as 0.038. 0.038, and what you have 0.038, and when you will calculate the result, then simply when you will calculate the result, this is 0.038, which is with the actually this thing 0.489 still you have on this side, and 2 you have on this side. So 0.038 plus your value you can write in this way, that 0.038, or simply you can write 0.04. So when you will use this 0.04, del r you have to write in this way, that del r is 0.04 multiplied by 0.489 divided by 2. So this will give you the value of your absolute uncertainty, which is coming as 0.009. So del r you have calculated as 0.009, and r you have already calculated. So if you want to write the answer, what you can write, 0.489 plus minus 0.009. You can take the you can say values in this way, yani you can write in powers as well, but yani 10 is to power minus 3 or something like this, but you need not to go into this much detail. So this is simply the answer, 0.489 plus minus 0.009 will be the value of your answer. So this is what we have. And of course, again, as I said before, that the purpose of solving these questions is just not to solve the question, but to practice what we have already done in the theory, and of course this will help us to understand what is going on. Here we are just going to solve another question, and this question is about the time and length. A simple pendulum, we can increase zoom the question. A simple pendulum may be used to determine a value for the acceleration of free fall g. Free fall g. Measurements are made of the length L of the pendulum and the time period. So length and the time period of the oscillation is given, length of the pendulum and its time period for oscillation. The values obtained with their uncertainties are as shown. Time with uncertainty and length with uncertainty. Calculate the percentage uncertainty in the measurement of time. So it's very simple. What you can write, Pt is equal to del t divided by t into 100, of course with plus minus. So del t is 0.03 and the value given as 1.93, and when you will multiply this value by 100, you will get the required percentage, which is nothing but, I am leaving the calculation for you, and the value is plus minus 1.6%. So this is what we have. So simply answer is nothing but your 1.6 plus minus 1.6%. So this is something which is very, very important. Remember this thing, that we are writing plus minus, but this is not absolute uncertainty. This is just the uncertainty in percentage. So this is something which is very important. On the other hand, the percentage of the uncertainty, in the length is required. So you can write PL plus minus del L over L into 100. Values are given. So del L is 1 and the value of the length is 92. So multiply by 100. This is giving you the answer as plus minus 1.086, or simply you can write 1.09, or to get a better value in or with a better significant figure, only you can write 1.1. So a better answer will be 1.1. So remember this thing, that we have to consider the values with appropriate uncertainties, with appropriate significant figures. So this is very important. Here the continuation of this question here, we have the relation between T, L and G is given by. So they have given you here the formula for G is equal to 4 pi square L over T square. Using your answers in A, calculate the percentage uncertainties in the value of G. So simply what you have, we know that we can write in this way that del G over G into 100 is equal to del L over L into 100 plus 2 del T over T into 100. But as we have already calculated this part and this part, so we have to just use those values to get the percentage uncertainty of G. So percentage uncertainty of G will be the percentage uncertainty of the length and percentage uncertainty of the T. So this will be the simple situation. We have already calculated the values 1.1 and 2 into 1.6. This will give us the answer of the percentage uncertainty of G, which is nothing but 4.3%. So 4.3% will be your answer. Simply here the percentage uncertainties we have already calculated in the previous part, and here we had to use those percentage uncertainties, and that's it. So this is something which is very simple. Here we have the part C. The values of length L and time T are used to calculate the value of G as 9.751 meter per second square. By reference, part A, by reference to the measurement of length L and time, suggest why it would not be correct to code the value of G as 9.751 meter per second square. So simply the point is that the instrument which you are using for the length and of course the you can say the least count of those instruments are very important. So simply what we are writing here, the least count of the instrument or the absolute uncertainties of given quantities are not allowing us to quote the value of G as 9.751 meter per second square. Yani least count is important. You cannot go beyond that value. So this is what we have. Then use your answer in B to determine the absolute uncertainty in G. So it's very simple. Here you have the situation of del G over G, and we know that we can write in this way that percentage uncertainty of G is nothing but del G over G into 100. In the previous part, you have already calculated the value of your percentage uncertainty in G. So this is nothing but 4.3 plus minus del G is required here. The uncertainty you need to calculate for the G thing, and the value of G is already is 9.81, and here you have 100. So you can calculate the value simply, and this is the situation. Yani if you will calculate the value of G by using this formula, then you will get the value 9.81, and here you have to calculate the value of del G, which is nothing at 0.4. So plus minus 0.4 you will have. And of course, as I said, that if you want to calculate, actually here we have only 2 marks, so we need not to calculate the value, but we can use directly the value of G here, and you know that value of G is 9.81. So simply you can do this way, that the value is 9.81 or 9.8, and over here 0.4 meter per second square, plus minus of course you have. So this is what you can do, and you have to calculate the result. So these are few you can say problems we have solved today, just to give you the idea that how you can use the formula which we have done for the uncertainty thing, and different operations we have considered here, any operations of multiplication, division, and exponential power, and plus minus, any subtraction, addition. So these are few related questions. Hopefully this discussion will give you help to understand what we have discussed in uncertainty. And of course there were few parts of the question which were about your systematic error and random error and so on. So if you are new on this on my channel, subscribe the channel, like the channel, and share this channel, so the other students can also get benefit of it. So if you are following this channel and you have already subscribed, then of course every new lecture you will get as soon as we will upload the lecture, and this will give you a better chance to get the understanding and of course the completion of the course with the help of this YouTube channel. Till then, till the next lecture, Allah Hafiz, take care.